So just like with differentiation, there's like different rules you can use, and this is just again just a couple more rules that you can use, and that's like a more full list you can look at. And then Jacob is going to go through just a quick little application of it. So the problem is Jacob is driving a car and traveling at 60 miles per hour, 88 feet per second on the highway. A deer bounds out onto the road and he slams on the brakes. When the deer is 155 feet away when the brakes are applied, the car decelerates constantly at 25 feet per second. Will Jacob's car hit the deer?
Okay, so we're going to kind of do this as a class problem, so we're going to need some participation. So the first thing in a problem like this is going to be, we have to find out what we know. So what do we know from this information?
Initial velocity,
Which is,
66 miles per hour or 88 feet per second. Probably use 88 feet per second because this deceleration is in feet per second too.
yeah. And then what else do we know? Yeah. The deer is 155 feet away.
We want to know what the final velocity equals 0 by 155 feet.
So final velocity equals 0. That's what we're hoping for. And then another thing we know is we actually know what the function of acceleration is going to be since it says it's constant. So acceleration over any time is going to be 25, actually negative 25 because we're slowing down. And then the other thing that's important to know is
Velocity
that
final equals
displacement, which is our distance, how far we are. The derivative of that equals velocity, which equals the antiderivative of acceleration. So with all this information, what we need to do first is figure out a velocity equation. So how can we figure that out from this stuff?
either that or remember your freshman physical science class.
Yeah, that's also true. But using calculus. So we know that if we integrate this acceleration, we'll be given velocity, right? So what is the velocity function going to be if acceleration is negative 25? It's going to be negative 25t. Then we have to add on the constant that because we can't know that right away. But luckily, we know that at time equals 0, the velocity is 88. So if we put 0 in for time here, that term would just cancel. So then we know c is going to equal 88. So the velocity function is negative 25t plus 88. And now we can use integration. Oh no, one more step first. So now what's the velocity going to be when the car stops? 0. So we want to take this as 0 equals negative 25t plus 88. And then we want to find the time where the car is going to stop. So if you solve that, t equals 3.52 or 88 over 25, whichever you prefer. Okay, so now that we know where we're starting